Hey everyone, welcome to this week's Azure Infrastructure Update. It is the 21st of April and a pretty quick update this week. As always, I have the chapters so you can jump to a particular update that interests you the most. On to new videos this week. I did a deep dive into Azure Active Directory App Proxy or Application Proxy, a way to take web-based applications on my network and expose them externally by leveraging Azure AAD and all of its identity capabilities like risk and conditional access to pre-authenticate and then give a nice secure access to them. Then a bit of fun using resource graph and as an example, finding duplicate private endpoints in a virtual network to the same resource. So really just playing around with resource graph and just showing how powerful it really is. So on to what's new on the compute side. So the Azure Kubernetes service, Azure CNI Overlay, has gone GA. There are various networking stacks I can use with Azure Kubernetes service. The big deal about this Azure CNI Overlay is the pods now use an IP space different from the node pools, which means it's different from the underlying virtual network. This means I don't have to worry so much about how big is the virtual network and the subnet for my AKS deployment, because the pods won't be taking IPs from that virtual network. Instead, they'll be using a different separate IP space. Now, this may sound a lot like KubeNet, but it doesn't have all the disadvantages of KubeNet. It's very, very fast in how it's programmed. I can have thousands of nodes in a cluster. So this is probably going to be one of the big go-forward networking solutions we're going to use for AKS. And I did a whole separate video on this if you want to dive into it. Then I mentioned this a few weeks ago, and I guess it got pulled, and now it is GA again. So the AKS Azure AD workload identity. So this is the new solution that replaces the old pod identity. And this actually works for any Kubernetes deployment. So yes, AKS, but this could also be in other clouds. It could be your own Kubernetes. It works for Linux and Windows. And it removes the custom pods we had to use for the previous pod identity solution and instead leverages the native Kubernetes OIDC federation capability. So what this is going to do now is pods can use a Kubernetes identity, i.e. a projected service account into the pod. It's going to get a Kubernetes issue token, and then using the OpenID Connect Federation endpoint of some other identity provider, for example, Azure AD, I can take my Kubernetes issue token, exchange it for an Azure AD token. When, of course, now I've got an Azure AD token, I can use that for any resource that trusts Azure AD, i.e. other Azure resources. This is a really useful capability. AKS fail fast upgrade. You say, well, if I'm going to fail, it's better to fail earlier rather than linger and fail later down the line. What this really means is, as new versions of Kubernetes come out, some features get deprecated. What this fail fast upgrade feature will let me do is it will warn me via an error message if it detects I'm using some API that has been deprecated in my target Kubernetes version I'm going to move to. So it's going to say, hey, we see you're using this API, this is deprecated, you should probably take some actions to stop using that, move to some other API before you go through with this upgrade. So it's going to give you a bit of notice on, hey, this will cause you a problem. AKS long-term version support. So this is an interesting one to me. AKS and Kubernetes supports a certain number of versions, kind of an N-2 thing, which gives you about a year of support of any Kubernetes version. What this long-term version support is going to do, starting with 1.27, so that the next one will actually be supported for 2 years. Now that support means you get support from Microsoft and you get security updates. So it's not going to be the full stack of all the other things that may come with it, but it will let me stay on a certain Kubernetes now for 2 years instead of really 1 year maximum. So if I have some product, some solution that's actually very hard for me to upgrade the Kubernetes version of, hey, I can now get a long-term support. This will not be for every version. I think the plan will be every 2 years, there'll be a new long-term servicing. So probably 1.3 3.3, I guess, would be the next one that would have another 2 years of long-term support. But hey, that's going to be available. Speaking of which, Kubernetes 1.26 is now gone GA for AKS, so I could go and upgrade and leverage that if I wanted to. OpenCost and Azure Kubernetes Service. So OpenCost is an open source project. Its goal is to give you cost FinOps insight into Kubernetes, the cost of my deployments, the utilization of my deployments. And so Microsoft are contributing to this OpenCost project, and specifically around AKS and Azure resource consumption. So the Azure consumption price sheets, that API feed, will now build into OpenCost so I can get the exact pricings of the Azure resources and my discounts. If as a customer I get specific discounts, so that will now be made available. I can also do a cost export from OpenCost and push to a CSV file that can be stored anywhere. It could be a local file, could be blob storage, so I can get a daily idea of my cost allocation and a daily idea of my utilization data. Azure Service Operator 2.0 has gone GA. Now, ordinarily, when I create Azure resources, I use some Azure primitive, native method. I can use an ARM JSON template, I can use Bicep, I might use a third party like Terraform to go and create the Azure resources. And then separately from that, I have my Kubernetes primitives. I create a YAML file to do my Kubernetes deployment. What the Azure Service Operator lets me do is from the Kubernetes primitive, i.e. its YAML file, I can deploy a whole set of Azure resources. So for example, I need a key and a key vault. So I need a key vault created. I need a database created. From my YAML file, for example, I can define and create Azure resources using this Azure Service Operator. And if we quickly go and look at just some examples, this goes through all of the list of supported resources. I'm not going to read all these out, but you can get an idea of all of the different types of resource. I would now be able to actually go and create from my Kubernetes primitives, my tooling, my YAML files, etc., that defines the rest of my environment. And then Azure Container Apps. Remember, Azure Container Apps abstract away AKS. They add Dapper to bring a whole set of capabilities for my microservices, adds Kida for my scaling, add sidecars for my networking, for different types of traffic shaping and splitting. That's now available in the Azure China Cloud in preview. And then Azure App Service has some new premium v3 offerings. So this is really, there's a P0 v3, which is tiny. It's 1 virtual CPU and 4 gigabytes of memory. Then there's also this new MV3 SKU, which is memory optimized. So this has a 1:8 ratio. For every 1 virtual CPU, you get 8 gigabytes of memory. And that goes from 2 to 32 virtual CPUs. So I've now got some more offerings there. On the storage side, Azure Storage Mover has gone GA. This is a migration solution for my on-premises NFS shares. So I have NFS storage, and I want to move that to Azure Blob Storage. It does not work with a hierarchical namespace, i.e. Data Lake today, but it's a whole set of tooling. I create projects and tasks to move from NFS into Azure Blob Storage. Elastic SAN preview is now available in more regions. They've added a whole set of new regions where I can use this Elastic SAN service. Elastic SAN, remember, basically presents itself as an iSCSI target. So iSCSI works over my network connection. It's just IP, which means if I'm consuming that service, it's using my network limits, not my, for example, disk limits of a virtual machine. So it's going to present an iSCSI target. I go and create volumes, which are part of volume groups. The performance will vary depending on the size of the Elastic SAN, and then it's shared between all the volumes in there. But that's now going to be available for more workloads. And really the goal of this is it's huge amounts of performance. So if I did have some maybe database, for example, and I was struggling with potentially the managed disk element and the limits are too small, or just, hey, the nature of it didn't fit my goals, well, now I could use an iSCSI target that's just native to the platform. Azure Files SMB now supports identity-based access for Linux clients. So this is, today I have to have those Linux clients joined to Active Directory domain services or Azure AD domain services. It does not work with the Azure AD Kerberos service. But my Linux machine can be joined to my Active Directory domain service or my Azure AD domain services. And then I integrate my Azure Files with that directory instance to now have the directory identity used for ACLs to go and access the content of that Azure Files SMB. So it's worked for Windows forever, and now my Linux clients can use it as well. And in miscellaneous, Azure CycleCloud 8.4.0 is released. And I actually had to go and look this up because I've never used this. So the whole idea of CycleCloud is it's a high-performance computing solution. So if I need a high-performance computing solution running on Azure, it helps orchestrate and manage the components. And really what that means is when I use high-performance computing, I use some kind of scheduler. Now, this scheduler is not an Azure-built scheduler. There's lots of existing ones out there. PBS Pro, Slurm, Grid Engine, HD Condor. You can create your own. And what this tool does is leverage the orchestrator, the scheduler of your choice, but then it will basically abstract away the underlying Azure resources needed to run the various jobs you have via that scheduler. So the VM scale sets, the disks, I just focus on the task and the scheduler I want to use. It does everything behind the scenes. So CycleCloud is not a scheduler, it uses some other scheduler. And basically just this new release adds a whole bunch of functionality to specific schedulers, to its interactions with different types of Azure resource, and also just some core functionality to CycleCloud itself. And that was it. I told you it was pretty quick this week. As always, I hope that was useful. Until next video, take care.